Hello students, your teacher here, Mr. Sarasinski with another episode of Algebra 1. This is your Module 3 review, and I apologize for not being here with you to go through this review together. I hope that you find this useful, and I hope that you are ready for your test tomorrow. All right, here we go. So first topic is solving systems by graphing. I have two of these on your test. So there's three scenarios. There's if they intersect and there's one solution, they're parallel and there's no solutions, and they're the same line and there's infinite solutions. Okay, so those are our three scenarios. All right, so for number one, we're going to graph the first function. We'll call that function A, and then we'll graph the second function. We'll call that function B. So the first function, we start at the y-intercept, so that's -1. And then the slope is up to right 3. Up to right 3, up to right 3, down to left 3. Down to left 3, down to left 3. Connect the dots. All right, same thing for the second function. Start at +4, and the slope is -1/1. So I go down 1, right 1, down 1, right 1, and there is my point of intersection. Now make sure that when you're doing these problems, you make it very clear where the point of intersection is. Okay, so that is the ordered pair 3, 1. All right, number two, function A. Function B. Now this one I have to do some work, not my favorite, but also I noticed something about these. I noticed that they're the exact same function, except the constant on the right is different. So my prediction right now is that this is going to be no solution, because when I move x and solve for y, these equations are going to have the same slope but with different y-intercepts. Watch. All right, so for A, x minus y equals 7. Subtract x. -y equals -x minus 7. Divide by -1. Y equals +1x plus 7. And then I do the same thing for the second. So we've got x minus y equals -4. Subtract x. -y equals -x minus 4, and then divide by -1. Y equals x plus 4. So let's graph them just so we can get the full picture now. Okay, so start at 7, 3, 6, 7. And we go up 1 over 1, up 1 over 1. Okay. And then, actually don't like that line very much. Not very straight. There we go, much better. And then my second equation starts at 4, and the slope is up 1 over 1. And you can see, hopefully, that those are parallel, even though my lines, again, not very straight, but they had the same slope. That's no solution. Okay, number 3, the first function, y equals x minus 1, that's starts at -1, up 1 over 1. And when they're in slope-intercept form, we don't really have to waste any time. We can go ahead and just put them on there. Okay. All right, and then for the second function, we got to do a little work. So let's go ahead and convert this to slope-intercept. Subtract x, and hopefully you're starting to notice I'm doing the same thing every time when I am converting to slope-intercept. Divide by 4. Now, -1 divided by 4 is -1/4, and 16 divided by 4 is 4. So we start at +4, and we go down 1, right 4. And so it didn't take me long to see where they intersect right there, which is the ordered pair 4, 3. And number 4, for number 4, both of these are in standard form, so I got to convert them. For A, we have 5x plus 2y equals 4. Subtract 5x. 2y equals negative 5x plus 4. Divide by 2. Y equals negative 5/2 x plus 2. Okay, second equation, 9x plus 2y equals 12. And we're going to subtract 9x. 2y equals negative 9x plus 12. Divide by 2. And y equals negative 9/2 x plus 6. All right, so here we go. First equation, start at 2, down 5, right 2. Down 5, right 2. Up 5, left 2. There we go. Now let me try to connect these dots. Okay. All right, and then the second function we have starting at positive 6, down 9, right 2. So down 6, right 2. And there is that. So these two intersect right there at 2, negative 3. All right, this is solving systems of equations by graphing. Remember, 3 scenarios: intersect, parallel, or the same line, infinite. All right, solving by substitution, we take what one of the variables equals and substitute it into the other equation and solve, and then take what you get for that variable and substitute and solve again. For numbers 9 and 10, they are not already solved for the variable, so we'll need to solve for one of the variables. And I want you to remember that the easiest one to solve for is the variable with the coefficient of 1. So in number 9, the easiest variable to solve for is y in the second equation. And in number 10, the easiest variable to solve for is x in the first equation. All right, here we go. So for number 5, if y equals x plus 2, then I can substitute x plus 2 for y in the second equation. 3x plus 3 times x plus 2 equals 6. Distribute. 3x plus 6, bring everything else down. 3x plus 3x is 6x. Subtract 6. 6x equals 0. Divide by 6. X equals 0. And it's totally fine to get 0 as a value. Okay, that just means that it goes through 0 on the x-axis. That's about all you can say. All right, now we got to substitute what x equals and find y. So y equals 0 plus 2, which is 2. All right, so our answer is 0, 2. All right, number 6, if x equals 3y, then I can substitute what x equals into the second equation for x. So 2 times 3y plus 4y equals 10. That's 6y plus 4y equals 10. That's 10y equals 10. And divide by 10, and you get 1. If y equals 1, then x equals 3 times 1. And 3 times 1 is 3. So the solution is 3, 1. All right, number 9. Number 9, I already said the easiest variable to solve for is y in the second equation. So I'm going to bring that over here real quick and solve by subtracting 4x. And I get y equals negative 4x plus 8. So if y equals that, then I can substitute that for y in the second equation. Or in the first equation, I'm sorry. Let's go to this one, the one we didn't just manipulate. So I get 5x plus 2 times negative 4x plus 8 equals 7. Distribute, that's negative 8x plus 16. Bring down the 5x. 5 minus 8 is negative 3x. Subtract 16. Negative 3x equals negative 9. Divide by negative 3. X equals 3. If x equals 3, let's take that. Let's put it right there and solve for y. So y equals negative 4 times 3 plus 8. That's negative 12 plus 8, which is negative 4. All right, so my ordered pair is 3, negative 4. And number 10, the easiest variable to solve for is x in the first equation. So x minus 2y equals 3. Add 2y to both sides. And x equals 2y plus 3. All right, so that's what x equals. Let's take it and let's put it for x in the second equation. So 4 times 2y plus 3 minus 8y equals 12. Distribute 8y plus 12 minus 8y equals 12. Combine like terms, they cancel out. So I get 12 equals 12, which is a true statement, which means infinite solutions. Means it's the same line. Okay. H, solving systems by elimination. And the first two examples, remember, we're trying to add or subtract the equations to get them to eliminate. If you add, they have to have opposite signs. And if you subtract, they have to have the same sign. So look at example 5, and I think this will make sense. In example 5, the x's both have the same sign. They both have a sign of 1. So if we subtracted, 1 minus 1 would give me 0. In number 5, if I added, x plus x would be 2x. And the y's have opposite signs. So that's a positive 1y and that's a negative 1y. And therefore, they would cancel out and equal 0. And so what I just showed you is that depending on whether they have the same sign or opposite signs, that's how you know whether to add or subtract. So same sign, subtract. Let's do that first. X minus x cancels out. Y minus negative y is like y plus y. So that's 2y. And negative 4 minus 2 is negative 6. Divide by 2, and y equals negative 3. If y equals negative 3, then x plus negative 3, I'm just substituting this into the first equation. All right, so I'm going to, well, plus negative 3 is, I'm just going to add 3. X equals negative 1. So the solution, negative 1, negative 3. Number 6. In number 6, the y's have the same coefficient, but they have opposite signs. So I can add the two equations. The y's eliminate. 2 plus 1 is 3x. And 14 plus negative 11 is 3. Divide by 3, x equals 1. If x equals 1, then let's put 1 in the first equation. 2 times 1 minus 3y equals 14. 2 times 1 is 2. Subtract 2 from both sides. Negative 3y equals 12. Divide by negative 3. Solution, 1, negative 4. Okay. Number 7. Okay. Number 7, I can tell that the x's already have opposite signs, so I can add them. Negative 3 plus 3 will cancel out. Negative 4 plus negative 1 is negative 5y. And negative 1 plus negative 4 is negative 5. Divide by negative 5, and y equals positive 1, negative, negative. If y equals 1, then negative 3x minus 4 times 1 equals negative 1. And just so you all are aware, I'm choosing the first equation each time to substitute back into, but you don't have to. You can use either one. Negative 4 times 1 is negative 4. Add 4 to both sides. Divide by negative 3. Okay. Solution, negative 1, 1. Last one in this section, we have the x's with the same coefficient and the same sign, so I subtract and they eliminate. 5 minus negative 7 is like 5 plus 7. And 4 minus negative 20 is like 4 plus 20. Divide by 12, y equals 2. If y equals 2, then 6x plus 5 times 2 equals 4. 5 times 2 is 10. Subtract 10. Divide by 6. So my solution, negative 1, comma, 2. All right, next page. And I promise it's going to get faster here. These problems just take a little while, some of those, the system problems. All right, so for topic 4, we're solving systems of linear inequalities, and all we do is graph these and shade them. The rules are greater than, less than is dotted. Greater than, equal to, less than or equal to is solid. And these are the line, right? Solid line, dotted line. And then greater than or equal to is above. And less than or equal to is below. All right, so let's use this information and let's graph these. Now, if they're not already in standard form, we'll have to, or if they're not already in slope-intercept form, we'll have to convert them. And remember, anytime you're solving an inequality, you have to remember to flip the sign if you multiply or divide by a negative. All right. Start at negative 1 for A, and then we go down 1, right 1, down 1, right 1, up 1, left 1. I'm just going to make a couple extra. And let's graph it. Oh, wait. Nope, that's not a solid line either. I messed up. All right, this is a dotted line. And if you forget to dot your line, you will lose a point. And since it's greater than, we shade above. Okay. Now, I'm going to do the same thing for B. Start at negative 5. Up 1, right 1, up 1, right 1, up 1, right 1. Let's go ahead and graph it. Oh, this one is also solid. Careful. See, I've done that twice. Luckily, I can click back and erase it. And since this is less than, I shade below. All right, so then the question says, or, you know, that these are where the solutions are, right? These are the ordered pairs that make both of those inequalities true. So if I were to give you an ordered pair, like, for example, I don't know, 6, negative 3, and ask you, is that a solution? Well, 6, negative 3 is right here, and that is definitely within the shaded region where they overlap, so I would say yes. Okay. All right, number 2. Both equations are already in slope-intercept form. Let's graph them. All right, so first one, start at 7, up 1, right 3, down 1, left 3, down 1, left 3, and it's a dotted line. Okay, and we shade it's less than, so we shade below. All right, now, second inequality, start at positive 4, and we go down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1. Okay. Remember, for inequalities, the place where they intersect doesn't matter, okay? And since it's greater than or equal to, I did get the solid line right that time, we shade above. So the solutions are in this area where the shading overlaps. So if I were to ask you, is point 0, negative 3 a solution. Well, 0, -3 is down here. That is not in the shaded region, so you would say no. Or not in the overlapping shaded region, I should say. All right, number 3. Let's bring a down here and get that one converted real quick. Less than or equal to 24. Subtract x. -4y is less than or equal to -x plus 24. Since it was positive, we make it plus. Then we divide by -4, and there we go, doing that thing that I was talking about a few minutes ago, where we're dividing each side by a negative. So this is going to be y is greater than or equal to a -1 divided by a -4 is a positive 1/4 x, and 24 divided by 4 is -6. So for equation A, we start at -6, and we go up 1, right 4, up 1, right 4. Down 1, left 4, down 1, left 4. Solid line. Shade above. All right. Now for line B, start at +1, up 2, right 1, up 2, right 1, up 2, right 1. Down 2, left 1. Oop, messed that one up. Down 2, left 1, down 2, left 1, down 2, left 1. And this is also a solid line. And we shade below. The overlap shading is in that area. And let's go on. All right, number 4, x equals, or x is less than -4. So -4 is right here for x. So let's make a dot, and then this would be a dotted line. Okay. And it shades to the left because it's pointing to the left, right? Okay. Oops. All right, now for equation B, let's do some work. Subtract 3x. 2y is less than or equal to -3x minus 2, divide by 2. And since we divided by a positive number, we do not have to flip the sign. Start at -1 and down 3, right 2. Down 3, right 2. Up 3, left 2. Up 3, left 2. This is going to be a solid line. And for this one, we're going to shade below. So where does the shading overlap? Well, the shading overlaps on this side of the red line. All right, next topic, topic 5, evaluating piecewise functions. And you have to look to the restrictions to tell which function to use. So for our first one, we have f of -4. Well, is -4 less than or equal to 2? No. It's greater than, wait, hold on. Yes, it is less than or equal to 2. It's way less than 2. So we're going to use the first function. So f of -4 equals -2 times -4 minus 4. And -2 times -4, and remember, you can just type that in your calculator, is +8. 8 minus 4 is 4. Part 2, or B, here, we've got f of 8. Well, 8 is greater than 2. So we're going to use this second function. F of 8 equals 4 times 8 minus 9. That's 32 minus 9, which is 23. And then f of 2, well, 2 is equal to 2. So we're going to use that first function, f of 2 equals -2 parentheses 2 minus 4. And -2 times 2 is -4. -4 minus 4 is -8. All right. Next part. So f of -1, let's see, is -1 less than or equal to -2? No. Is -1 between -2 and 4? Yes. So we're using that center function 2 times negative 1 minus 1. That's negative 2 minus 1, which is negative 3. And f of negative 4, let's see, which one are we going to use? So negative 4 is less than negative 2. Check. So we're going to go f of negative 4 equals negative 4 minus 1. And that is negative 5. And for our last part, f of 5 is greater than 4. So I'm going to be using this function. And f of 5 equals negative 3 parentheses 5 plus 8. And negative 3 times 5 is negative 15. Negative 15 plus 8 is negative 7. Couldn't get that to go there for some reason. My stylus has been giving me a hard time. Wait, let me just make sure I didn't skip anything. Okay. Page. Next page. Graphing absolute value functions. This is where we make a table of values. And we start with the vertex. Remember, these are in vertex form. So x minus h plus k, where h and k are the vertex. Okay. Just be careful because when you're taking h out, remember it has to be the opposite. So the vertex for number 7 is going to be 1, negative 1. And I'm going to put that in the middle of my table. The vertex for number 8, oops, didn't mean to make that so long, is going to be negative 5, 0, because there's no k. The vertex for number 9 is going to be 0, negative 7, because there's no h. And the vertex for number 10 is going to be negative 3, positive 6. Remember, the h value always changes, okay? All right, so now let's set up our tables around those. And less than is 0, negative 1, 2, and 3. Less than is negative 6, negative 7. Greater, negative 4, negative 3. We got negative 2, negative 1, 1, 2. Negative 4, negative 5, negative 2, negative 1. All right, so now I'm going to use my calculator, and I'm going to type those equations into my y equals, and then I'm going to find what y does equal. So for x is negative 1, minus 1 is negative 2, positive 2 minus 1 is 1. All right, now when it's 0, 1 minus 1 is 0. So there we go. Let's graph it. Start at negative 1, 1. Negative 1, positive 1 right here. 0, 0. 1, negative 1. 2, 0. Just like that. Domain is all real numbers. Let's do a different color for that. It'll always be all real numbers. And the range, if it opens up, it's greater than or equal to, and it's the y value of the vertex, negative 1. All right, number 8. Let's graph it. Negative 7. It's going to be positive 8. I'm sorry, negative 8. Negative 6. Negative 4. Okay. So we've got negative 7, negative 8. Negative 6, negative 4. And negative 5, 0. And this makes sense why it's reflected and why it's so skinny, because it's being multiplied by negative 4, right? So the domain, all real numbers. And since this opens down, y is less than or equal to the y value of the vertex, 0. All right, number 9. Let's see. I'm gonna get some fractions this time. So this will be negative 6.6 repeating. And this will be negative 6.6 repeating. And then 2, that'd be negative 6.3 repeating. So we start at negative 2, negative 6.3, negative 2, negative 1, 2, 3, 4, 5, 6, and it's a little more than 6, so right about there. And then negative 1, 6.6, so that's a little further down between 6 and 7. And then 0, negative 7, and then it just reflects. But you can see that this graph, man, it really flattened out, which makes sense because our A is a fraction, it's less than 1. And the graph shifted down 7. Okay, domain, always all real numbers. It opens up, so y is greater than, and the y value of the vertex is 7, negative 7. All right, for number 10, negative 5, 2, 4. Doing some mental math, negative 4, so negative 1, positive 1, negative 1, positive 5. So 5 and 4. All right, let's graph it. Negative 5, positive 4, right there. Negative 4, positive 5. And negative 3, positive 6. Just like that. This looks good. Opens down because A is negative. Up 6, left 3. Domain, all real numbers. Opens down, y is less than or equal to the y value of the vertex, 6. All right, done. Next, transformations. And we talked about the vertex form, A times x minus h plus k. A controls reflections, stretch, and compression. H controls the horizontal shift, so left and right. And K controls the vertical shift. Now remember, H is tricky. Everything else is pretty straightforward, but H is always the opposite. All right, so for number 10, describe the transformation. Down 3. Number 11, it's plus 7 inside the absolute value, so that's left 7. All right, we've got a negative in front of the absolute value, which means it's reflected. And then we have 4 being subtracted, which means right 4. It's always the opposite for H. 13, 4 for A, and so this is stretched by 4, and K is 1, so that is up 1. Number 14, A is 1/3, that is compressed by a factor of 1/3. Number 15, H is positive 2 or plus 2, that's going to be left 2. And then K is minus 5, that's going to be down 5. 16, A is negative 2. That's reflected and stretched by a factor of 2. And then that's going to be stretched. And H is negative 1, or x minus 1 inside parentheses, so that's right 1. All right, 17. This is a stretch. This is a tricky stretch because 4/3 is a fraction, but it's greater than 1. And there's no H, so there's no horizontal shift. K is plus 2, so up 2. All right, for the last few here, we are writing the equation from the transformation. So remember, the parent function is y equals the absolute value of x. Everything else, we're just adding on to that. So 6 units right would be x minus 6. Reflected in the x-axis would be a negative a. Then 2 units up. So nothing inside the absolute value, and then after the absolute value plus 2. Vertically stretched by a factor of 5, so that means A is 5. And then translated 1 unit left. That means inside the absolute value, I have X plus 1. Number 21, translated 3 units right and 4 units down. So 3 units right would be minus 3, and then 4 units down would be minus 4. 22, vertically compressed by a factor of 2/3, then reflected. That means 2/3 is negative. No H, no K. 23, stretched by a factor of 2 and then translated 9 units down. So that means A is 2. There's no H value, and K is -9. And for 24, vertically compressed by a factor of 1/4. So A is 1/4, shifted 1 unit left. So inside the absolute value, X plus 1. I am your teacher. This is the way. See ya Thursday. Bye.